Hello everyone. So up until this point, we have seen what linear equations in two variables actually are, right? Then we have learned four different ways of solving linear equations in two variables. First, we saw the graphical method. Then we looked at the substitution method. Then we saw how we use the elimination method. And last, we studied about the cross multiplication method. Have you ever wondered that there might be some scenarios where the equations that we get might not be in the form of a pair of linear equations? Now, in those kind of scenarios, how do we solve them? Well, there are multiple different ways, but in some cases, the equations can be brought down into the format of a pair of linear equations. And in those cases, we can use the knowledge of linear equations to solve those equations. Let's see a couple of examples and see how we tackle those kind of problems. So now let's have a look at these pair of equations. So the first equation tells us that 1 by 2x minus 1 by y is equals to minus 1. And the second equation tells us that 1 by x plus 1 by 2y is equals to 8. Now these equations look very complex, right? We don't yet know how we calculate these kind of, or how we solve these kind of equations. What we have to do here is we have to think of some way in which we can transform these equations and bring it in the format of a pair of linear equations, because we know how to solve a pair of linear equations, right? So what we can do here is in the place of 1 by x, we can substitute another variable, and in the place of 1 by y, we can substitute another variable, right? So what we'll do is we'll assume that the first variable that we take is u, which is equals to 1 by x. So we'll take another variable which will represent in the terms of x, right? So u is equals to 1 by x, and the second variable that we'll take is v, which will say v is equals to 1 by y. So now if I use these two values and I try to rewrite these equations, I can write the first equation in the format 1 by, so the first equation is 1 by 2x minus 1 by y is equals to minus 1, right? Now in the place of 1 by x, I can substitute the value u, and in the place of 1 by y, I can substitute the value v. So I can rewrite this equation as u by 2 minus v is equals to minus 1, right? If I rearrange this, I get the equation as u minus 2v is equals to minus 2. So now this equation is in the format of a linear equation in two variables, right? Where the variables are u and v. Now let's look at the second equation. So the second equation tells us 1 by x plus 1 by 2y is equals to 8. So now again I'll do the same thing here, right? In the place of 1 by x, I'll substitute u, and in the place of 1 by y, I'll substitute the value v. So I can rewrite this equation as u, right, plus 1 by 2v is equals to 8. Sorry. U plus v by 2 is equals to 8. So now I can rearrange this equation and represent it in the form of 2u plus v is equals to 16. So now this becomes the second equation. This also resembles the format of a linear equation in two variables, right? So now I have two equations which resemble the format of linear equations in two variables, where the variables are u and v. Now I can solve this pair of linear equations to get the values of u and v, right? Once I have the values of u and v, I can use these expressions to find the values of x and y. So this is how we can solve this. So now in the next step, what we'll do is we'll solve these pair of linear equations in two variables. So now that we have the two equations that we call a pair of linear equations in two variables, we know how to solve them, right? We have seen four different methods of solving a pair of linear equations in two variables. So go ahead and give it a try. Try to use any of the four methods to solve these pair of linear equations. I'll use the method of substitution to solve this pair of linear equations. So from the equation 1 that we have, I can derive u is equals to 2v minus 2. Right? So I can take the value 2v to the right hand side, which gives me the value of u as 2v minus 2. Now I can substitute this value of u, which we have found in the equation 3, in the equation 2, and we can rewrite that equation as 2 times. So instead of u, we'll put the value 2v minus 2 plus v is equals to 16. So now if I simplify this, this gives me 4v minus 4 plus v is equals to 16. So if I take this 4 to the right hand side, this gives me 5v is equals to 20, right? 16 plus 4 is 20, which gives me the value of v as 20 by 5 or 4. So I have found out that the value of v is 4. Now I can substitute this value of v in the equation 3 to get the value of u, right? So if I can say that u is equals to 2v minus 2, right? So if I put the value of v, which is 4, in this equation, I get 2 into 4 minus 2, which is 8 minus 2, which gives me 6. So now on solving these pair of linear equations, we have figured out that the value of variable u is 6 and the value of variable v is 4. So we have found the values of u and v. But the question is not yet complete, right? What we are supposed to find were the values of x and y. So now we had two expressions, right? So we had substituted u is equals to 1 by x and v is equals to 1 by y. So I can use these two values to calculate these two expressions to calculate the values of x and y. So here I can say that u is equals to 1 by x, right? Which gives me the expression x is equals to 1 by. So if I put the value of u that we calculated from these pair of linear equations, the value of u was 6. So this gives me the value of x as 1 by 6. Right? And if I use that expression, which is v is equals to 1 by y, I can calculate the value of y as well, right? So the expression is v is equals to 1 by y. So I can also rewrite this as y is equals to 1 by v. So if I substitute the value of v, which was 4, I get the value of y as 1 by 4. So we see how we solved these complex pair of equations in two variables by just representing them in the terms of some other variables and bringing them in the format of linear equations in two variables. Using that, once we have those two equations, we can solve them using any of the methods that we have learned about, and we can use the substitution expressions to find the values of the original variables. So this is how you can tackle such complex equations as well. Let's try and practice this concept a little more with the help of a couple of solved examples.